Deep in the historical records of Vienna, Spain, lies a cache of ancient wealth known as the Treasure of Vienna. Among the gold and silver bracelets, archaeologists found something that defied the local timeline. Intrigued, it is a small, hollow sword hilt covered in gold detailing, attached to a severely oxidized dark iron blade. Artifacts found alongside this weapon, combined with the style of the craftsmanship, placed its creation over 3,000 years ago, during the Bronze Age. There is a problem with that date. Smelting Earth's iron ore requires furnaces capable of reaching over 1,500 degrees Celsius, a technology humanity wouldn't develop for several more centuries. By all laws of history, this weapon should not exist. Because of this chronological paradox, the sword sat in museum collections for decades as an unexplained anomaly, while historians debated how it could have been manufactured. Recently, a team of scientists decided to bypass the debate. They subjected the relic to modern 21st-century metallurgical testing. Metallurgy is the scientific study of the physical and chemical behavior of metallic elements. The outcome of this test would determine whether our timeline for human technological development was incomplete. Testing a 3,000-year-old antiquity is notoriously difficult, as researchers cannot simply cut a sample off the blade and melt it down in a lab. Instead, the team used mass spectrometry, a non-destructive scanning technology that bounces light off the metal to reveal its exact chemical ingredients. Mass spectrometry identifies chemicals by measuring the mass-to-charge ratio of the atoms within a sample. The resulting data showed that while the blade was iron, its specific mixture of trace elements differed from standard Earth metallics. This chart shows the elemental makeup of the artifact compared against standard Earth mined iron ore. It reveals high levels of nickel and cobalt mixed within the iron. Earth's geology dictates strict limits on natural ore formation. No known terrestrial mine produces this specific chemical signature. Because this precise ratio of metals exceeds the terrestrial maximum, the iron was never mined from the Earth's crust. It came from somewhere else. If the material was not extracted from the ground, the scientists had to test the only remaining alternative hypothesis: the metal fell from space. This visualization overlays the artifact's elemental spectrum with the established chemical signature of a known iron-nickel asteroid. The data is a locking match. The source of the ancient metal was a meteorite, a chunk of debris that survived atmospheric entry and impacted the Iberian Peninsula. Lacking the tools to dig deep into the Earth for ore, ancient societies scavenged the landscape for these fallen rocks. This material is known as meteoritic iron. The paradox was solved. Bronze Age ancestors didn't invent high-heat iron smelting early. They harvested pure, ready-to-forge iron directly from the sky. Even with pure material, shaping meteoritic iron requires skill. A metalsmith had to recognize the unusual rock, heat it, and repeatedly strike it over a stone anvil without the benefit of steel tools. Looking at the Spanish treasure through this scientific lens, we see an object forged from the cosmos. To the humans who found and shaped this material, this was more than metallurgy. It was a piece of the sky brought down to Earth. Possessing a weapon made from the sky elevated the object from a tool to a sacred item or a symbol of royal status. As non-destructive technology allows us to look closer at the ingredients of our past, it leaves us with one question: how many other ancient artifacts in our museums are secretly hiding an extraterrestrial origin?